The darkness you see when you close your eyes at night, that infinite black canvas behind your eyelids, is not empty. It is not nothing. It is the closest thing your human brain can comprehend to what lies beyond the edge of everything you know. Everything you've been told exists. Everything science has dared to measure. But here's what will shatter your understanding of reality in the next hour. That darkness, that nothingness you think you know, is actually teeming with something so incomprehensible that your mind will struggle to hold on to it. The Big Bang did not bang. The universe did not begin. And the edge of everything you call reality is not an edge at all. It is a doorway. You have been lied to, not maliciously, not intentionally, but lied to nonetheless by the very limitations of human perception, by the crude instruments we've built to peer into the cosmos, by the mathematical models that comfort us with their neat equations and tidy explanations. Every textbook that told you the universe began 13.8 billion years ago, every documentary that showed you galaxies spiraling through space like cosmic pinwheels, every scientist who confidently declared that space and time emerged from a singular point of infinite density. They were describing shadows on a cave wall, patterns of light that merely hint at a reality so vast and strange that our language fails, our mathematics crumbles, and our very concept of existence becomes as primitive as a child's crayon drawing of the sun. What if I told you that right now, as you listen to these words, you are not just on a planet orbiting a star in one galaxy among billions? What if you are simultaneously existing in dimensions your mind cannot perceive, swimming through quantum fields that connect you to every particle that has ever existed, embedded in a cosmic structure so intricate and alive that calling it a universe is like calling an ocean a puddle? What if the Big Bang was not a beginning but a ripple, not an explosion but an exhalation, not the birth of everything, but merely one moment in an eternal dance of creation and destruction that has no beginning and will have no end? The night sky you gaze up at, dotted with those distant points of light, is not showing you the universe. It is showing you an echo, a reflection, a glimpse of something that exists behind and beneath and beyond what your eyes can see. Every star you've ever wished upon, every constellation that has guided human navigation for millennia, every galaxy that the Hubble telescope has revealed in all its spiral majesty, these are not the actors in the cosmic play. They are the shadows cast by something infinitely more complex, more beautiful, more terrifying than anything your human imagination has ever conjured. Consider this. You are made of atoms that were forged in the nuclear furnaces of dying stars. Your carbon and oxygen and iron born in stellar explosions that lit up alien skies billions of years before Earth even existed. You are literally, scientifically, poetically made of starlight. But those atoms, those fundamental particles that comprise your physical being, are themselves made of something that exists in a realm where the word made loses all meaning. At the quantum level, particles don't exist in specific places. They exist in clouds of probability, in superpositions of all possible states simultaneously, in entangled relationships that transcend the speed of light and mock our understanding of cause and effect. You are not just connected to the universe. You are the universe experiencing itself subjectively, temporarily, through the biological machinery of your brain and nervous system. But here's what will keep you awake at night. If you are the universe experiencing itself, then what lies beyond the universe is also you. What exists in the realm before the Big Bang, what inhabits the space outside of space, what dreams in the dimensions that mathematics can describe but human consciousness cannot visualize, This too is experiencing itself through you, right now, as you process these words. The cosmic microwave background radiation that scientists point to as evidence of the Big Bang, that faint whisper of ancient light that supposedly represents the afterglow of creation itself, is not a relic of the beginning. It is a message, a transmission, a signal from something that was there before time began, and will be there after the last black hole evaporates into nothingness. It is the universe's way of remembering something that your scientists call the beginning, but which is actually a transformation, a phase transition, a moment when one kind of existence shifted into another, like water becoming ice, or ice becoming steam. Think about infinity for a moment, not as a mathematical concept, not as the symbol that looks like a sideways 8, but as an actual concrete reality. If space is infinite, and our best observations suggest it might be, then everything that can happen will happen, is happening, has already happened somewhere in the vast expanse beyond what we can observe. There is a region of space, impossibly distant but mathematically certain, where another version of you is living a life identical to yours, down to the last quantum detail. There is another region where you made every decision differently. There is a region where Earth never formed, where the sun never ignited, where the Milky Way never coalesced from the cosmic dust. But infinity is not just about space. If time extends infinitely in both directions, and the mathematics of certain cosmological models suggests it might, then this moment, this exact configuration of atoms and thoughts and possibilities has occurred before and will occur again, infinite times across infinite eons. The universe is not just expanding and cooling toward a heat death. It is cycling, breathing, transforming through phases of existence that make our current phase of stars and galaxies seem like a fleeting dream between deeper, stranger states of being. The edge of the observable universe, that sphere of space, approximately 93 billion light-years in diameter, beyond which we cannot see, because light has not had enough time to reach us, is not an edge at all. It is a horizon, like the horizon you see when standing on an ocean shore. Beyond that horizon lies more ocean, more waves, more water extending perhaps forever. Beyond the edge of our observable universe lies more universe, more space filled with galaxies and stars and planets, possibly teeming with life forms so exotic that they would consider us as alien as we might consider them. But what about before the Big Bang? What about the realm that existed when there was no space to expand into, no time to measure duration, no matter to organize into atoms and molecules, and eventually into conscious beings capable of asking these questions? The mathematics tells us that time itself began with the Big Bang, that asking what came before is like asking what lies north of the North Pole. But mathematics is a tool built by human minds to describe patterns, and human minds evolved to survive on the African savanna, not to comprehend the deepest structures of reality. There are theoretical physicists who speak of the multiverse, of bubble universes spawning from quantum fluctuations in a higher dimensional space they call the bulk. There are cosmologists who describe eternal inflation, where new regions of space-time are constantly being born, each with their own physical laws, their own values for the fundamental constants, their own big bangs occurring like raindrops, forming in an infinite cosmic storm. There are string theorists who envision 11 dimensions of reality, with our familiar 3 dimensions of space and one of time being merely the surface phenomena of something far more complex and beautiful. Waters. If all of these theories are simultaneously true and completely inadequate, what if reality operates on so many levels, through so many dimensions, across so many scales of existence, that our human attempts to understand it are like an ant. Reality operates on so many levels, through so many dimensions, across so many scales of existence, that our human attempts to understand it are like an ant trying to comprehend a symphony. The ant can detect vibrations, can sense changes in air pressure, can even respond to the music in rudimentary ways. But the ant has no concept of melody, harmony, rhythm, emotion, the cultural context that gives the music meaning, the intentions of the composer, the skill of the musicians, the acoustic properties of the concert hall. You are that ant, and reality is that symphony. But unlike the ant, you have the capacity to sense that there is something greater, something more complex and beautiful than your immediate perception can grasp. You have the ability to feel awe, to experience wonder, to intuit the presence of mystery even when you cannot solve it. This capacity for transcendence, this ability to reach beyond your biological programming and glimpse something infinite, is not an accident of evolution. It is evolution recognizing itself, the universe developing the ability to experience its own vastness through temporary arrangements of matter that we call conscious beings. The Big Bang, if it happened at all, was not the beginning of existence. It was existence remembering how to exist. It was consciousness condensing into matter, matter organizing into complexity, complexity developing awareness, awareness recognizing its own cosmic nature. What we call the expansion of the universe. It's actually the expansion of awareness, the growth of consciousness as it explores all possible ways of experiencing itself. Every atom in your body has existed for billions of years before becoming part of you, and will continue existing for billions of years after your biological processes cease. But the pattern that is you, the specific arrangement of matter and energy that generates your unique perspective, your particular way of experiencing and interpreting reality. This pattern has never existed before and will never exist again. You are a cosmic accident that was always destined to happen. A temporary eddy in the flow of universal consciousness that somehow developed the ability to contemplate the very flow that created it. The darkness between the stars is not empty. It is full of potential, pregnant with possibilities, vibrating with quantum fields that connect every particle to every other particle across all of space and time. The space inside atoms, which your high school chemistry teacher told you was mostly empty, is actually seething with virtual particles popping in and out of existence, borrowing energy from the quantum vacuum and paying it back before the universe's accounting system notices the debt. What lies beyond the universe is not another place. It is another way of being. It is existence without the constraints of space and time, consciousness without the limitations of matter and energy, awareness without the boundaries of self and other. It is what you are when you are not being you, what the universe is when it is not being physical, what reality is when it doesn't need to be real. The question is not whether there is something beyond the universe. The question is whether you are ready to discover that you have always been that something, temporarily forgetting your infinite nature to experience the exquisite limitations of being human, the bittersweet beauty of existing in a cosmos that appears to be separate from you, but which is actually your own deepest nature expressing itself as space and time and matter and consciousness. This is not philosophy. This is not speculation. This is the most practical truth you will ever encounter, because it is the truth of what you are. Every breath you take is the universe breathing through you. Every thought you think is the cosmos thinking with your brain. Every emotion you feel is existence itself, experiencing the full spectrum of what it means to be aware. The Big Bang did not bang because there was nothing to make a sound. no medium to carry vibrations, no ears to hear. But something did happen 13.8 billion years ago, something that transformed one kind of reality into another, something that allowed the infinite to experience itself as the finite, the eternal to play at being temporal, the one to dream itself as many. You are living inside that dream, but you are also the dreamer. The universe you think you inhabit is actually inhabiting you, using your nervous system as its instrument of perception, your consciousness as its method of self-recognition. What lies beyond the universe is the dreamer awakening, reality recognizing its own infinite nature. You discovering what you have always been beneath the temporary costume of human identity. Picture the most powerful telescope humanity has ever built, floating in the cold vacuum of space, its golden mirrors perfectly aligned to capture light that has traveled for billions of years to reach this moment. The James Webb Space Telescope, our most advanced eye on the cosmos, peers deeper into space and further back in time than any instrument before it. But what it sees challenges everything we thought we knew about beginnings, about edges, about the fundamental nature of existence itself. Every image it sends back is not just a photograph, it is a time machine, showing us the universe as it was when it was young, when the first stars were igniting in the primordial darkness, when galaxies were just beginning to coalesce from the cosmic web of dark matter and energy. But here's what will disturb your understanding of cosmic time. Those ancient galaxies, those primordial stars, those early structures that formed supposedly just a few 100 million years after the Big Bang. They look too mature, too organized, too complex for their age. It's as if you opened a photo album expecting to see baby pictures and instead found portraits of fully grown adults. The early universe, according to our current models, should have been a chaotic soup of simple elements, mostly hydrogen and helium, slowly cooling and clumping together under the influence of gravity. Instead, we see galaxies with intricate spiral structures, massive black holes that shouldn't have had time to grow so large, star formation rates that defy our understanding of cosmic evolution. This is not a minor discrepancy in the data. This is the universe telling us that our story of creation, our neat timeline of cosmic evolution, our confident assertions about how everything began and developed are fundamentally incomplete. The cosmos is showing us that it remembers something we have forgotten, that it contains information from before the beginning, that it carries patterns and structures that predate what we call the dawn of time. Consider the cosmic microwave background, that faint whisper of radiation that permeates all of space, the afterglow of the Big Bang itself. For decades, scientists have studied this radiation as if it were a fossil, a relic from the universe's infancy that tells us about conditions, approximately 380,000 years after the initial moment of expansion. We've mapped its temperature fluctuations with exquisite precision, used its patterns to determine the universe's age and composition, treated it as the most ancient light we can observe. But what if the cosmic microwave background is not a fossil, but a message? Not an afterglow, but a transmission from something that exists beyond our current understanding of space and time? The patterns in this radiation are too perfect, too precisely calibrated to have emerged from random quantum fluctuations in the early universe. They suggest a level of fine-tuning, a degree of intentional structure that makes cosmologists uncomfortable, because it implies something beyond the realm of purely physical processes. The temperature variations across the sky form patterns that seem to encode information, as if the universe's first light is actually carrying data from whatever realm existed before space and time began their cosmic dance. When you look up at the night sky, you are seeing approximately 5,000 stars with your naked eye, each one a sun potentially warming planets, where life might be asking the same questions you are asking now. But those visible stars represent less than 0.001% of all the stars in the observable universe. The Milky Way alone contains between 200 and 400 billion stars, and there are at least 2 trillion galaxies within the range of our most powerful telescopes. The numbers become so vast that they cease to have meaning, like trying to comprehend infinity by counting grains of sand on all the beaches of Earth. Yet even this incomprehensible multitude of stars and galaxies represents only 5% of the universe's total content. The remaining 95% consists of dark matter and dark energy, substances so mysterious that we can only detect their effects, not their essence. Dark matter outweighs ordinary matter by a ratio of 5-to-1, forming an invisible scaffolding upon which all visible structures are built. Every galaxy, including our own, is embedded in a vast halo of this invisible substance, held together by its gravitational influence, shaped by its distribution throughout space. Dark energy is even more enigmatic, comprising 70% of the universe's energy budget, while remaining completely undetectable except through its effect on cosmic expansion. It is not matter in any sense we understand, not energy as we typically conceive it, but something that permeates empty space itself, causing the universe to expand at an accelerating rate. The very fabric of space-time is being stretched by this mysterious force, carrying galaxies away from each other faster and faster, driving the cosmos toward a future of increasing isolation and darkness. But here's what should keep you awake at night, contemplating the nature of reality. If dark matter and dark energy comprise 95% of everything that exists, then the universe you think you know, the stars and planets and galaxies, the atoms and molecules that make up your body, the electromagnetic radiation that allows you to see and communicate, represents only a tiny fraction of what's actually out there. You are living in what amounts to a shadow play, observing the small portion of reality that interacts with light while remaining blind to the vast majority of cosmic existence. The early universe was not just hot, it was a furnace where time itself was still learning to move, where space had not yet decided on its final dimensions, where the laws of physics were still crystallizing into the forms we observe today. In the first fraction of a second after the Big Bang, temperatures reached levels where matter and energy were indistinguishable, where particles and antiparticles annihilated each other in cascades of pure radiation, where the fundamental forces that govern reality today were unified into a single incomprehensible superforce. During this epoch, known as the Planck era, the universe was smaller than a proton, but contained all the mass energy that would eventually become the hundreds of billions of galaxies we observe today. Quantum effects dominated over classical physics, and space-time itself existed in a state of quantum superposition, simultaneously experiencing all possible configurations of geometry and topology. The universe was not evolving according to deterministic laws, but exploring all potential pathways through the landscape of possible realities. This period lasted only 10^43 seconds, a duration so brief that light could travel only the smallest measurable distance in physics, the Planck length. Yet within this infinitesimal moment, the universe underwent inflation, expanding from subatomic to macroscopic size faster than light could cross the distance from one side to the other. This inflation was not gradual, but explosive, increasing the universe's volume by a factor of 10^78 in less time than it takes a photon to cross an atomic nucleus. But inflation creates a paradox that cosmologists struggle to resolve. If the universe expanded faster than light during this period, then regions of space that are now on opposite sides of the observable universe could never have been in contact with each other. They could never have exchanged information, never have reached thermal equilibrium, never have coordinated their properties. Yet when we observe the cosmic microwave background, we see that these widely separated regions have virtually identical temperatures, as if they had somehow communicated and agreed on a common state, despite being causally disconnected. This is known as the horizon problem, and it suggests that the universe remembers a time before inflation, a period when all regions of space were in intimate contact with each other, sharing information and energy in ways that our current physics cannot explain. The cosmic microwave background is not just showing us the afterglow of the Big Bang, it is preserving the memory of a pre-inflationary state where the universe existed as a unified whole, where space and time had not yet separated into the discrete dimensions we experience today. The mathematics of general relativity, Einstein's theory of gravity and space-time, breaks down completely during the Planck era. The equations that describe the curvature of space-time, the bending of light around massive objects, the orbital mechanics that keep planets circling their stars, become meaningless when applied to the extreme conditions of the early universe. Space-time itself becomes quantum mechanical, existing in superpositions of different geometries, fluctuating between existence and non-existence, creating and destroying virtual universes in patterns that mathematics can describe but human intuition cannot grasp. This mathematical breakdown is not a failure of Einstein's theory. It is the theory telling us that we have reached the boundary of its applicability, the edge of what general relativity can describe. Beyond this boundary lies a realm that requires a quantum theory of gravity, a unified description of space-time and matter that physicists have been seeking for over a century. String theory, loop quantum gravity, causal set theory, emergent gravity. These are attempts to peer beyond the mathematical veil that conceals the deepest layer of physical reality. But what if the mathematical breakdown is not a limitation of our theories, but a reflection of something more fundamental? What if the Planck era represents not just the earliest moment of our universe, but the interface between existence and non-existence, the boundary where being emerges from non-being, where something arises from nothing through processes that transcend the distinction between physical and metaphysical? The quantum vacuum, which physicists sometimes call empty space, is actually seething with activity. Virtual particles constantly pop in and out of existence, borrowing energy from the vacuum and paying it back before violating the uncertainty principle. The vacuum energy, the zero-point energy that remains even when all matter and radiation have been removed, is so enormous that it should, according to quantum field theory, curve space-time so severely that the universe would collapse into a point smaller than an atom. Yet the universe does not collapse. Instead, it expands, accelerates its expansion, creates more space faster than gravity can pull it back together. This suggests that our understanding of the quantum vacuum is fundamentally flawed, that the relationship between quantum mechanics and general relativity involves principles we have not yet discovered. The vacuum is not empty, but full, not nothing, but everything, not the absence of existence, but the source from which all existence emerges. Dark energy might not be a mysterious force permeating space, but space itself, the intrinsic tendency of the quantum vacuum to expand, to create more, room for virtual particles to exist, to explore all possible configurations of matter and energy. The acceleration of cosmic expansion might be the universe's way of creating more opportunities for consciousness to emerge, more space for life to evolve, more time for awareness to contemplate its own nature. The cosmic web, that vast network of filaments and voids that gives large-scale structure to the universe, resembles nothing so much as a neural network, the branching patterns of neurons in a brain. Galaxies cluster along these filaments like synapses, connected by flows of dark matter and energy that carry information across billions of light years. The voids, those vast empty regions between the filaments, are not truly empty, but filled with dark energy, the medium through which cosmic information propagates. If the universe has the structure of a neural network, then what is it thinking? What kind of consciousness could emerge from a brain the size of the observable universe, with trillions of galaxies as its neurons, with billions of years as its reaction time? The cosmic microwave background might be the universe's first thought, the moment when cosmic consciousness awakened to its own existence and began the long process of understanding itself through the evolution of matter and the emergence of life. But consciousness is not confined to biological brains. Quantum information theory suggests that information, not matter or energy, is the fundamental constituent of reality. Every particle in the universe carries information about its properties, its history, its relationships with other particles. Every quantum interaction is an exchange of information, a moment when one part of the universe learns something about another part. The universe is not just expanding and cooling, it is computing, processing information, exploring the space of all possible thoughts and experiences. The fine-tuning of the fundamental constants, the strength of gravity, the mass of the electron, the speed of light, appears to be calibrated with extraordinary precision to allow for the existence of stars, planets, and life. Change any of these values by even a tiny fraction, and the universe would be sterile, devoid of complexity, incapable of generating the conditions necessary for consciousness to emerge. This fine-tuning suggests either an extraordinary cosmic coincidence or an underlying principle that selects for universes capable of generating awareness. The anthropic principle attempts to explain this fine-tuning by arguing that we observe a life-friendly universe because we are here to observe it. In an infinite multiverse, where all possible values of the fundamental constants are realized somewhere, we necessarily find ourselves in a universe compatible with our existence. But this explanation raises more questions than it answers. Why? Should the multiverse exist at all? What determines the range of possible values for the constants? What is the relationship between consciousness and the physical laws that govern reality? String theory suggests that the fundamental particles are not point-like objects, but tiny vibrating strings, existing in a space-time with up to 11 dimensions. The different vibrational modes of these strings correspond to different particles, like the different notes produced by a vibrating guitar string. But most of these dimensions are curled up so small that they are invisible at everyday scales, hidden from direct observation, yet influencing the properties of matter and energy in subtle ways. The shape of these extra dimensions, their topology, and geometry determines the fundamental constants of physics, the masses of particles, the strengths of forces. There are an enormous number of possible ways to curl up the extra dimensions, creating what string theorists call the landscape of possible universes. Each point in this landscape corresponds to a different set of physical laws, a different reality with its own unique properties and possibilities. Our universe occupies one tiny region of this vast landscape, one particular configuration of hidden dimensions that happens to allow for complexity and consciousness. But the landscape extends far beyond our local region, encompassing realities where time runs backward, where gravity repels instead of attracts, where consciousness takes forms we cannot imagine. The question is not whether these other realities exist. The mathematics of string theory suggests they must, but whether we can ever access them, communicate with them, or understand our relationship to them. The holographic principle, emerging from studies of black hole thermodynamics, suggests that all the information in any volume of space can be encoded on its boundary, like a hologram that contains a three-dimensional image on a two-dimensional surface. This principle implies that our three-dimensional reality might be a projection from information encoded on a two-dimensional boundary, that the depth and solidity we experience might be illusions created by a more fundamental reality existing in fewer dimensions. If the holographic principle is correct, then the universe you think you inhabit is actually a shadow cast by information existing in a lower dimensional space. Your thoughts, your memories, your sense of being a separate individual in a vast cosmos are all patterns in this holographic projection, real in their own way but not fundamental, meaningful within the context of the projection but not describing the deepest level of reality. The black holes scattered throughout the universe are not just cosmic vacuum cleaners sucking up matter and energy. They are information processing systems, quantum computers exploring the space of all possible computations. The event horizon of a black hole, that boundary beyond which nothing can escape, is not a barrier but an interface, a place where information is transformed from one form to another, where the distinction between inside and outside loses its meaning. Hawking radiation, the thermal emission that causes black holes to slowly evaporate, carries information out of the black hole in encoded form. This information is scrambled, randomized, seemingly destroyed by the process of gravitational collapse and thermal emission. But quantum mechanics forbids the destruction of information, suggesting that the radiation must somehow preserve all the information that fell into the black hole, encrypted in correlations too subtle for current technology to decode. The black hole information paradox represents a fundamental conflict between general relativity and quantum mechanics, between our understanding of gravity and our knowledge of information theory. The resolution of this paradox might require a complete revision of our concepts of space, time, matter, and information. It might reveal that black holes are not destroyers of information, but transformers, not endings, but transitions, not voids, but wombs where new forms of reality are born. The cosmic horizon, that boundary beyond which we cannot see because light has not had enough time to reach us, might be another kind of event horizon, another interface between different forms of reality. Just as the black hole horizon conceals information in forms we cannot access, the cosmic horizon might conceal realities that exist beyond the reach of our instruments and observations, universes that share the same space-time but exist in dimensions we cannot perceive. If the universe has no edge, then where does it begin? If space is infinite, then what lies beyond infinity? If time had a beginning at the Big Bang, then what is the nature of the timeless realm from which time emerged? These questions probe the boundaries of human language and understanding, pointing toward mysteries that might be fundamentally unsolvable by minds that evolved to navigate a world of medium-sized objects moving at moderate speeds. Yet the questions themselves are significant, not because they have answers, but because they reveal the limits of conceptual thought, the boundaries where logic meets paradox, where science encounters mystery. The universe is not just stranger than we suppose, it is stranger than we can suppose, operating according to principles that transcend our current categories of understanding, while remaining intimately connected to the deepest structures of consciousness and awareness. The cosmic setup is not a collection of facts about space and time, matter and energy, stars and galaxies. It is a mirror reflecting the nature of the observer, a koan revealing the paradoxes of existence, a teaching story about the relationship between consciousness and reality. Every cosmological discovery is also a psychological revelation. Every astronomical observation, a moment of self-recognition. Every journey into the depths of space, simultaneously, a voyage into the depths of the mind that contemplates space. What lies beyond the universe is not another place, but another way of asking questions. Not a different realm of existence, but a different mode of being. The cosmic setup is setting you up to recognize what you are, where you are, and why the questions you are asking are the universe's way of coming to know itself through the temporary but precious instrument of your conscious awareness. Imagine reality as a film reel, where time is not flowing, but every moment already exists, frozen in the eternal now of space-time. Each frame contains a complete universe, a full configuration of every particle and wave, every thought and dream, every heartbeat and stellar explosion. What you experience as the passage of time is consciousness moving through this reel, illuminating one frame after another, creating the illusion of temporal flow where none actually exists. This is not science fiction. This is the block universe theory, one of the most profound and disturbing implications of Einstein's relativity, suggesting that your past, present, and future all exist simultaneously in the four-dimensional structure of space-time. Einstein himself was troubled by this implication of his own theory. When his lifelong friend, Michel Besso, died, Einstein wrote to Besso's family, "For us believing physicists, the distinction between past, present, and future is only a stubbornly persistent illusion." The man who revolutionized our understanding of space and time spent his final years grappling with what his equations revealed about the nature of temporal existence, the reality of simultaneity, the meaning of causation in a universe where all events exist timelessly in the eternal structure of space-time. The mathematics is unambiguous. According to general relativity, there is no universal now, no cosmic moment that defines simultaneity across all of space. What counts as now depends on your reference frame, your velocity, your position in a gravitational field. Two observers moving relative to each other will disagree about which events are simultaneous, which happened first, which are in the past, and which are in the future. Time is not a river flowing from past to future, but a landscape that can be traversed in different directions, depending on how you move through space. This relativity of simultaneity destroys our intuitive notion of temporal order and opens the door to paradoxes that make science fiction seem tame by comparison. If there is no universal now, then the future already exists somewhere in space-time, waiting to be experienced by consciousness as it moves along its world line through the four-dimensional manifold. Your death already exists, your birth still exists, and this moment of reading these words exists eternally alongside every other moment of your life in the timeless structure of reality. But if the future already exists, then what about free will? Are you choosing to read these words, or are you discovering a choice that was already embedded in the fabric of space-time? The block universe theory suggests that causation is not a temporal process where earlier events influence later ones, but a geometric relationship where all events are connected through the intrinsic structure of space-time itself. Your thoughts are not causing your actions. They are aspects of the same four-dimensional pattern, different cross-sections of your world line through the eternal manifold of existence. The singularities that lurk at the heart of black holes and at the beginning of the Big Bang represent points where the equations of general relativity break down completely, where the curvature of space-time becomes infinite, where the normal rules of physics cease to apply. A singularity is not just a very dense region of matter. It is a boundary of space-time itself, a place where the concepts of place and when lose their meaning. At a singularity, the distinction between space and time dissolves, matter and energy become indistinguishable, and the laws of physics transform into something unrecognizable. When you fall into a black hole, and according to quantum mechanics, you are constantly falling into virtual black holes that pop in and out of existence in the quantum vacuum, you experience something that challenges the fundamental assumptions of physics. From your perspective, you fall smoothly through the event horizon and are eventually torn apart by tidal forces as you approach the central singularity. But from the perspective of an outside observer, you never quite reach the event horizon. Instead, you appear to slow down and fade away. Your image red-shifted into invisibility as time dilation stretches your final moments into eternity. Both perspectives are correct according to general relativity, but they describe completely different realities. This is not just a mathematical curiosity. It reveals something profound about the nature of observation and reality. The universe does not have a single objective description independent of observers. Instead, reality depends fundamentally on the relationship between the observer and the observed, the measurer and the measured. What you experience as real depends on where you are, how fast you are moving, and how you choose to measure and interpret the phenomena around you. The information paradox that emerges from black hole physics represents one of the deepest puzzles in modern physics. When matter falls into a black hole, it carries information with it. Information about the quantum states of particles, i.e., arrangements of atoms, the patterns that define the structure of complex systems. According to general relativity, this information disappears forever when it crosses the event horizon and ultimately reaches the singularity where space-time ends. But according to quantum mechanics, information cannot be destroyed. The quantum states of particles can be transformed, scrambled, encoded in complex ways, but the information they contain must be preserved in some form. This principle, known as unitarity, is fundamental to quantum theory and has been verified in countless experiments. Yet black holes seem to violate unitarity by destroying information irreversibly, creating a fundamental conflict between our two most successful theories of physics. Hawking radiation, the thermal emission that causes black holes to evaporate, slowly over time, initially seemed to make the information paradox even worse. The radiation appears to be completely thermal, carrying no information about the matter that fell into the black hole. As the black hole shrinks and eventually disappears, the information that fell into it seems to be lost forever, violating the fundamental principles of quantum mechanics and threatening the logical consistency of physics itself. But recent developments in theoretical physics suggest a resolution that is more bizarre and beautiful than anyone initially imagined. The holographic principle, emerging from string theory and black hole thermodynamics, proposes that all the information in a volume of space can be encoded on its boundary. Applied to black holes, this means that information falling past the event horizon is simultaneously encoded on the hole's surface, existing in two places at once without violating any physical laws. This holographic encoding is not just a theoretical abstraction. It suggests that the three-dimensional reality you experience might be a holographic projection from information stored on a two-dimensional boundary. Your sense of depth, of moving through three-dimensional space, of existing as a distinct object in a world of separate things, might be illusions created by the projection of more fundamental information existing in fewer dimensions. The ADS-CFT correspondence, one of the most profound discoveries in theoretical physics, demonstrates that a quantum field theory on the boundary of a space can be completely equivalent to a gravitational theory in the bulk of that space. This duality between gravity and quantum mechanics, between curved space-time and flat quantum fields, suggests that these seemingly different aspects of reality are actually different descriptions of the same underlying phenomenon. String theory takes this unification even further, proposing that the fundamental constituents of reality are not particles, but tiny vibrating strings existing in a space-time with up to 11 dimensions. The different vibrational modes of these strings correspond to different particles: electrons, quarks, photons, gravitons, like different musical notes played on the same instrument. But most of the dimensions in which these strings vibrate are curled up so small that they are invisible at macroscopic scales, hidden from direct observation, yet determining the properties of everything we see and experience. The landscape of string theory is vast beyond imagination, containing approximately 10^500 possible vacuum states, each corresponding to a different configuration of the compact dimensions and hence a different set of physical laws. This number is so large that it exceeds the number of atoms in the observable universe by a factor that itself exceeds the number of atoms in the observable universe. Each point in this landscape represents a different possible universe with its own unique physics, its own fundamental constants, its own possibilities for complexity and consciousness. Our universe occupies one tiny corner of this vast landscape, one particular vacuum state that happens to allow for the existence of stable atoms, long-lived stars, and the complex chemistry necessary for life. But the landscape extends far beyond our local region, encompassing realities where electrons are heavier than protons, where electromagnetic forces are stronger than gravity, where time has multiple dimensions and space curves back on itself in impossible ways. The eternal inflation theory suggests that this landscape is not just a mathematical abstraction, but a physical reality, with different regions of space-time exploring different vacuum states as quantum fluctuations drive the universe through phase transitions from one state to another. Our observable universe might be just one bubble in an infinite foam of universes, each bubble containing its own Big Bang, its own expansion history, its own evolution toward complexity or simplicity. But eternal inflation creates its own paradoxes that push the boundaries of scientific reasoning. In an eternally inflating multiverse, everything that can happen will happen, not just once, but infinitely many times. There are infinitely many copies of you reading these words, infinitely many versions where you made different choices, infinitely many realities where the laws of physics are slightly or dramatically different. The concept of probability becomes meaningless when everything possible occurs with infinite frequency. The measure problem in cosmology asks how we should assign probabilities to different outcomes in an infinite multiverse, where every possible outcome occurs infinitely often. This is not just a technical issue for cosmologists, it strikes at the heart of scientific reasoning itself. How do we test theories that make predictions about infinite collections of universes? How do we distinguish between different models, when both predict that every possible observation will be made by some observer somewhere in the multiverse? Loop quantum gravity offers an alternative to string theory that preserves the discrete quantum nature of space and time at the smallest scales. According to loop quantum gravity, space-time is not smooth and continuous, but granular, made up of discrete units called quanta of space and time. At the Planck scale, the fabric of reality resembles a foam or network rather than the smooth manifold described by classical general relativity. This quantization of space-time has profound implications for cosmology and the nature of singularities. In loop quantum gravity, the Big Bang singularity is replaced by a quantum bounce, where a previous contracting universe reaches minimum size and then begins expanding again. The Big Bang becomes not the beginning of time, but a moment of transition between different epochs of cosmic evolution, a bridge connecting our expanding universe to a previous collapsing phase. The implications of quantum gravity extend beyond cosmology to the nature of information and computation. If space-time is discrete rather than continuous, then the universe has a finite information processing capacity, a maximum rate at which it can perform computations, and a maximum amount of information it can store. This digital physics hypothesis suggests that reality might be fundamentally computational, with the laws of physics emerging from underlying computational processes operating on discrete bits of information. But computation requires a substrate, a physical system that can manipulate and store information. In digital physics, this substrate is space-time itself, the quantum foam of loop quantum gravity serving as the hardware on which the software of physical law operates. The particles and forces you observe are not fundamental entities, but emergent phenomena arising from the computational processes that govern the evolution of information in the quantum substrate of reality. The causal set approach to quantum gravity takes discreteness even further, proposing that space-time is fundamentally composed of discrete events connected by causal relationships. In this view, space and time are not fundamental, but emergent, arising from the statistical properties of large collections of causal events. The smooth space-time of general relativity is an approximation that works at large scales, like the way a fluid appears continuous, even though it is composed of discrete molecules. Emergence is a central concept in modern physics, the idea that complex phenomena can arise from simple underlying rules without being reducible to those rules. Consciousness emerges from the activity of neurons. Life emerges from the chemistry of organic molecules. Galaxies emerge from the gravitational interactions of dark matter and ordinary matter. But emergence is not just a feature of complex systems. It might be the fundamental principle by which reality constructs itself at every level. The holographic principle suggests that space itself is emergent, arising from quantum entanglement, between degrees of freedom on a lower dimensional boundary. Recent work in quantum gravity has shown that the geometric properties of space, distances, angles, volumes, can be derived from the pattern of entanglement between quantum systems. Space is not a container in which things exist, but a relationship between quantum information, a way of organizing and connecting the fundamental units of reality. Quantum entanglement, the phenomenon Einstein called spooky action at a distance, creates correlations between particles that transcend the limitations of space and time. When two particles become entangled, measuring one instantaneously affects the other regardless of the distance separating them, as if information travels faster than light or exists outside the normal flow of time. Bell's theorem proves that these correlations cannot be explained by any local hidden variable theory, demonstrating that reality is fundamentally non-local and interconnected at the quantum level. But entanglement is not just a curious feature of quantum mechanics. It might be the fundamental structure from which space-time itself emerges. The ER-EPR conjecture proposes that quantum entanglement and space-time wormholes are the same phenomenon viewed from different perspectives. Particles that are entangled are connected by microscopic wormholes through higher dimensional space, creating shortcuts through the fabric of reality that allow for instantaneous correlation across any distance. This connection between entanglement and geometry has profound implications for the nature of space and time. The Einstein-Rosen bridges that connect distant regions of space-time might not be exotic solutions to general relativity, but fundamental features of quantum reality, the mechanism by which information and correlation propagate through the universe. The non-locality of quantum mechanics and the connectivity of space-time might be different aspects of the same underlying phenomenon. The many-worlds interpretation of quantum mechanics takes the implications of quantum non-locality to their logical extreme, proposing that every possible outcome of every quantum measurement actually occurs, but in different branches of the universal wave function. When you observe the spin of an electron, you do not collapse the wave function into a single state, but become entangled with one branch of a splitting universe, while other versions of you become entangled with other branches. In the many worlds, interpretation. The universe is constantly branching into multiple parallel realities. each containing observers who experience a different sequence of quantum outcomes. The wave function never collapses. It continues to evolve unitarily, preserving all possibilities in an ever-expanding tree of parallel worlds. Your consciousness follows one particular branch through this tree, creating the illusion of a single, definite reality, while countless other versions of you explore different branches. But the many worlds interpretation raises profound questions about the nature of consciousness and identity. Are all the branches equally real? Or does consciousness somehow select which branch to experience? What determines which branch you find yourself in? And what is the relationship between the different versions of yourself in parallel worlds? If every possible version of you exists somewhere in the multiverse, then what makes you uniquely you? The quantum Zeno effect demonstrates that observation itself can freeze the evolution of quantum systems, preventing transitions between states. By the act of continuous measurement, this suggests that consciousness might play a more active role in shaping reality than previously thought, not just observing the universe, but participating in its creation through the choices of what to measure and when to measure it. But measurement in quantum mechanics is not limited to conscious observation. Any interaction between quantum systems constitutes a measurement that can cause wave function collapse or decoherence. The universe is constantly measuring itself through the interactions between particles, creating a vast network of quantum information processing that might be the substrate of physical reality itself. Quantum field theory, the framework that unifies quantum mechanics and special relativity, describes particles as excitations in underlying fields that permeate all of space. The electromagnetic field gives rise to photons. The electron field gives rise to electrons. The Higgs field gives rise to the Higgs boson that endows other particles with mass. But these fields are not just mathematical abstractions. They are the fundamental constituents of reality, more basic than the particles they create. The quantum vacuum, the lowest energy state of these quantum fields, is not empty, but filled with virtual particles that constantly pop in and out of existence, borrowing energy from the vacuum and paying it back before violating the uncertainty principle. These virtual particles are not merely theoretical constructs, but have measurable effects, creating the Casimir force between closely spaced conducting plates and contributing to the anomalous magnetic moment of the electron. But the energy density of the quantum vacuum, calculated from quantum field theory, is approximately 10^120 times larger than the observed energy density of empty space. This is the cosmological constant problem, the worst prediction in the history of physics, suggesting either that our understanding of quantum fields is fundamentally flawed, or that there is a mechanism that cancels most of the vacuum energy. With extraordinary precision, supersymmetry was proposed as a solution to this problem, suggesting that every known particle has a supersymmetric partner that contributes negative energy to the vacuum, potentially canceling the positive contributions of ordinary particles. But searches for supersymmetric particles at the Large Hadron Collider have found no evidence for the hypothetical partners, raising questions about whether supersymmetry exists in nature or whether the cosmological constant problem requires a different solution. The landscape of string theory might provide that solution, with most of the 10^500 possible vacuum states having cosmological constants that are far too large to allow for the existence of galaxies and stars. Our universe might be a rare exception where quantum corrections to the vacuum energy nearly cancel, leaving a small residual that manifests as dark energy and drives the accelerating expansion of space. But this anthropic explanation raises uncomfortable questions about the nature of scientific explanation itself. Are we forced to abandon the goal of predicting the fundamental constants from first principles and accept that their values are environmental accidents determined by the requirement That they allow for the existence of observers? Does the existence of consciousness impose constraints on the laws of physics, or does physics determine the possibilities for consciousness? The fine-tuning of the fundamental constants is so precise that changing any of them by even a small fraction would render the universe incapable of supporting complexity and life. The strength of the strong nuclear force is calibrated to within 1% of the value required for carbon production in stellar cores. The mass difference between protons and neutrons is fine-tuned to allow for the existence of hydrogen while preventing the decay of all protons into neutrons. The electromagnetic coupling constant is precisely balanced to allow for stable atoms without making stellar nucleosynthesis impossible. This fine-tuning suggests either an extraordinary cosmic coincidence, a vast multiverse in which we inhabit one of the rare life-friendly regions, or an underlying principle that selects for universes capable of generating consciousness. The strong anthropic principle proposes that the universe must have properties that allow for the development of observers, while the weak anthropic principle merely notes that we observe a life-friendly universe because we are here to observe it. But the anthropic principle is not really an explanation. It is a recognition of our ignorance about why the universe has the properties it does. Invoking the anthropic principle is like explaining why you won the lottery by noting that someone had to win. It shifts the question from why the constants have their observed values to why there is a selection mechanism that favors life-friendly universes, or why consciousness should constrain the fundamental laws of physics. The participatory universe hypothesis, proposed by physicist John Wheeler, suggests that observers are not passive recipients of information about a pre-existing reality, but active participants in the creation of that reality through their choices of what to observe and measure. In this view, the universe does not have definite properties independent of observation, but exists in a state of quantum superposition until conscious observers make measurements that retroactively determine what was always true. Wheeler's delayed choice. Experiments demonstrate that decisions made by observers in the present can apparently influence the behavior of photons in the past, determining whether they behaved as waves or particles millions of years ago when they were emitted by distant stars. This suggests that the boundary between observer and observed is not as clear as classical physics assumed, and that consciousness might be woven into the fabric of reality at the most fundamental level. The itty from bit hypothesis extends this idea even further, proposing that physical reality emerges from information processing, that matter and energy are secondary phenomena arising from the manipulation of binary distinctions by conscious observers asking yes or no questions about the nature of reality. In this view, the universe is not made of things but of choice, not of particles, but of decisions, not of matter, but of meaning. But meaning requires a context, a framework of interpretation that gives significance to information. The universe, as a whole, cannot have meaning in the way that human experiences have meaning, because there is nothing outside the universe to provide that context. Unless the universe is embedded in something larger, something that transcends the physical realm entirely, something that could provide the interpretive framework necessary for meaning to emerge. The grandfather paradox is not just a thought experiment from science fiction. It is a window into the logical structure of causality itself, revealing deep tensions between our intuitive understanding of cause and effect and the mathematical possibilities permitted by general relativity. If you could travel back in time and prevent your grandfather from meeting your grandmother, you would prevent your own birth and hence your ability to travel back in time in the first place. This creates a causal loop that seems to violate the logical consistency of space-time, suggesting either that time travel is impossible or that reality has mechanisms for preventing paradoxes that we do not yet understand. But time travel is not forbidden by the laws of physics. General relativity permits solutions where closed time-like curves exist, allowing objects to travel into their own past and potentially create the very conditions that enabled their time travel. The Gödel solution describes a rotating universe, where time travel is possible, while traversable wormholes could theoretically connect different moments in time as well as different regions of space. The mathematics of general relativity treats time as just another dimension of space-time, with no fundamental distinction between moving forward or backward through time and moving in any direction through space. The Novikov self-consistency principle proposes that the universe has built-in mechanisms that prevent paradoxes from occurring, ensuring that any time travel that takes place is consistent with the observed history of events. According to this principle, if you travel back in time, you are always part of the historical events you are trying to change. Your attempt to kill your grandfather would necessarily fail, not because of some external intervention, but because the failure is built into the causal structure of space-time itself. This raises profound questions about free will and determinism. In a universe where time travel is possible, if the self-consistency principle is correct, then the future constrains the past just as much as the past constrains the future. Your choices are not free, but predetermined by the requirement that they be consistent with all the events that have already occurred, including events that occur after you make your choices. Causality becomes circular rather than linear, with effects influencing their own causes in an endless loop of mutual determination. The many worlds interpretation offers a different resolution to time travel paradoxes, suggesting that traveling to the past creates a new branch of the universal wave function rather than changing existing history. When you travel back in time to kill your grandfather, you succeed, but you kill a version of your grandfather in a parallel timeline while leaving your original timeline intact. You cannot change your own past because you no longer exist in the same branch of reality as that past, but you can create new timelines where different events occur. But this solution raises its own paradoxes about the nature of identity and continuity across parallel worlds. If you kill your grandfather in a parallel timeline, are you responsible for the death of a person who is not actually your grandfather? What is the relationship between you and the version of yourself that exists in the timeline where your grandfather dies? Are you the same person existing in multiple timelines? Or are you distinct individuals who happen to share a common origin? The measurement problem in quantum mechanics creates a different kind of paradox that strikes at the heart of what we mean by objective reality. According to the standard Copenhagen interpretation, quantum systems exist in superpositions of multiple states until they are measured, at which point the wave function collapses and the system takes on a definite value. But this interpretation requires a fundamental distinction between the quantum realm, where superpositions are possible, and the classical realm, where objects have definite properties. The problem is that the boundary between quantum and classical is arbitrary and observer-dependent. There is no fundamental scale or complexity threshold that determines when quantum superposition gives way to classical definiteness. Large molecules like Buckminster fullerene have been observed in quantum superposition, and there is no theoretical reason why larger and more complex objects could not also exhibit quantum behavior under the right conditions. The Schrödinger's cat thought experiment illustrates this paradox by applying quantum superposition to a macroscopic object. According to quantum mechanics, the cat should exist in a superposition of dead and alive states until observed. But this violates our everyday experience. The cats are either dead or alive, never both simultaneously. The paradox reveals the difficulty of extending quantum mechanical concepts to the macroscopic world while maintaining logical consistency. Decoherence theory attempts to resolve this paradox by showing how interactions with the environment cause quantum superpositions to decay rapidly at macroscopic scales, creating the appearance of wave function collapse without requiring any fundamental distinction between quantum and classical realms. But decoherence does not actually solve the measurement problem. It merely shifts it from the system being measured to the environment that causes decoherence. The problem of quantum measurement becomes even more acute when we consider that observers themselves are made of quantum mechanical particles. If the observer is described by a wave function that can exist in superposition, then what causes the observer's wave function to collapse when making a measurement? The chain of measurement extends indefinitely, with each observer requiring another observer to collapse their wave function, leading to an infinite regress that cannot be resolved within the framework of quantum mechanics alone. This has led some physicists to propose that consciousness plays a fundamental role in wave function collapse, that the subjective experience of observation is what transforms quantum possibilities into classical actualities. But this interpretation raises more questions than it answers. How does consciousness interact with quantum systems? What level of consciousness is required to cause collapse? Do bacteria collapse wave functions? What about computers or thermostats that respond to environmental changes? The hard problem of consciousness represents one of the deepest mysteries in science and philosophy. The question of how subjective experience arises from objective physical processes. Even if we understand how the brain processes information, how neurons fire and networks form, how sensory data is integrated and memories are stored, we still face the question of why there is something it is like to be conscious, why there is an inner subjective dimension to experience that seems to transcend purely physical description. Some philosophers argue that consciousness is an emergent property of complex information processing systems, that subjective experience arises naturally when information is integrated and processed in sufficiently sophisticated ways. But emergence is not really an explanation. It is a description of what we observe without explaining why or how complex systems should give rise to inner experience. Why should information processing feel like something from the inside rather than simply occurring in the dark? The combination problem asks how individual conscious experiences can combine to create unified conscious experience. Your brain contains billions of neurons, each potentially conscious in some minimal sense, but your experience is unified rather than fragmented into billions of separate micro-experiences. How do these potentially conscious components combine to create the single, integrated experience of being you? What determines the boundaries of consciousness, the distinction between different conscious entities? Panpsychism proposes that consciousness is a fundamental feature of reality, present in some form at every level of organization, from elementary particles to complex brains. In this view, your conscious experience is built up from the micro-experiences of the particles that compose your body, combined and integrated through the physical processes that occur in your nervous system. But this merely shifts the hard problem to a different level. How do micro-experiences combine, and what determines which physical processes give rise to unified macro-experience? Integrated information theory attempts to quantify consciousness by measuring how much information a system integrates above and beyond the information processed by its individual components. According to this theory, consciousness corresponds to integrated information, and any system that integrates information, including some artificial systems and potentially even simple networks, has some degree of conscious experience. But this leads to counterintuitive conclusions, such as the possibility that photodiodes or protons might have rudimentary forms of consciousness. The binding problem asks how the brain creates unified perceptual experiences from the activity of millions of specialized neurons processing different aspects of sensory information. When you see a red ball moving across your visual field, different groups of neurons are processing the color, shape, motion, and location of the object. But you experience these as aspects of a single unified object, rather than as separate sensory qualities. How does the brain bind these distributed neural activities into coherent perceptual experiences? Temporal binding poses an additional challenge. Neural processing takes time, with different sensory modalities and different aspects of perception requiring different amounts of time to process. Yet your conscious experience seems to occur in a unified present moment, with all sensory information apparently integrated simultaneously. How does the brain create this illusion of temporal unity from neural processes that occur at different speeds and with different delays? The global workspace theory proposes that consciousness arises when information becomes globally available across different brain systems through a neural network that broadcasts information widely throughout the brain. But this theory faces the same explanatory gap as other approaches. It describes the neural correlates of consciousness without explaining why global broadcasting should give rise to subjective experience rather than simply more sophisticated information processing. The question of artificial consciousness becomes increasingly urgent as we develop more sophisticated artificial intelligence systems. If consciousness is substrate-independent, as many theories suggest, then there is no reason why silicon-based systems could not be conscious in the same way that carbon-based brains are conscious. But how would we recognize artificial consciousness if we encountered it? What tests could distinguish genuine consciousness from sophisticated behavioral simulation? The Turing test evaluates whether a machine can engage in conversations indistinguishable from those of a human, but this test measures behavioral sophistication rather than inner experience. A system could pass the Turing test while having no more subjective experience than a calculator, or it could fail the test while possessing rich inner experiences that are simply difficult to communicate through language. The Chinese room argument challenges the idea that computational processes alone can give rise to understanding or consciousness. Even if a system can process language in sophisticated ways, manipulating symbols according to rules without understanding their meaning, this does not necessarily imply genuine comprehension or conscious experience. But this argument assumes a sharp distinction between syntax and semantics, between symbol manipulation and meaning, that may not reflect the actual nature of understanding and consciousness. Embodied cognition theories suggest that consciousness and intelligence are not purely computational, but depend fundamentally on the physical embodiment of cognitive systems in bodies that interact with the environment. In this view, consciousness emerges from the dynamic interaction between brain, body, and world, not from abstract information processing alone. This suggests that artificial consciousness might require not just sophisticated computation, but also appropriate embodiment in systems that can interact with their environment in meaningful ways. The frame problem in artificial intelligence asks how cognitive systems can determine which aspects of their knowledge are relevant to their current situation and which can be ignored. This problem becomes acute when we consider that any realistic representation of the world contains vast amounts of information, most of which is irrelevant to any particular decision or action. How do conscious systems solve this frame problem? And what does this tell us about the nature of consciousness itself? Free will represents another fundamental paradox that cuts across science, philosophy, and everyday human experience. Our subjective experience strongly suggests that we have the ability to make genuine choices, to be the ultimate authors of our actions, to shape our futures through our decisions. But deterministic physical theories suggest that every event, including human decisions, is the inevitable result of prior causes stretching back to the beginning of time. Quantum mechanics introduces an element of genuine randomness into physical processes, but random events are not freely willed events any more than determined events are freely willed events. If your decisions are based on quantum coin flips in your brain, they are not more free than if they were based on deterministic processes. They are simply more unpredictable. Freedom seems to require something beyond both determinism and randomness, a form of causation that is neither mechanistic nor random, but somehow genuinely creative. The experience of deliberation suggests that consciousness can intervene in the causal flow of physical events, that mental states can influence brain states in ways that go beyond simple physical causation. But this appears to violate the causal closure of physics, the principle that every physical event has a sufficient physical cause. If mental states can cause physical events, then where does the extra energy come from? How can non-physical consciousness push around physical particles without violating conservation laws? Compatibilism attempts to reconcile free will with determinism by redefining what we mean by freedom and choice. According to compatibilist theories, an action is freely chosen if it flows from the agent's own desires, beliefs, and reasoning processes, even if those mental states are themselves determined by prior causes. Freedom is not the absence of causation, but the right kind of causation, where actions are caused by the agent's own mental states rather than by external coercion or constraint. But this redefinition of freedom seems to miss what we care about when we worry about free will. If your desires and beliefs are themselves the inevitable products of genetic and environmental factors beyond your control, then in what sense are actions based on those desires and beliefs truly your responsibility? The compatibilist notion of freedom seems to collapse into a sophisticated form of determinism, where the feeling of choice is just another link in the causal chain rather than a genuine break in that chain. Hard determinists accept this conclusion and argue that free will is indeed an illusion, a compelling but false belief that emerges from our inability to perceive the full causal history of our actions. In this view, moral responsibility is a useful fiction that encourages beneficial behavior, but does not reflect any genuine metaphysical distinction between praise and blame, punishment and reward. We hold people responsible not because they are truly responsible, but because the practice of holding people responsible influences future behavior in socially beneficial ways. But this instrumentalist approach to moral responsibility faces the paradox of self-defeat. If people come to believe that free will is an illusion, will they continue to behave as if they are responsible for their actions? Studies suggest that belief in free will affects behavior, with people who doubt the existence of free will showing increased tendencies toward dishonest and antisocial behavior. This creates a pragmatic argument for maintaining belief in free will even if it is metaphysically false. The paradox of free will becomes even more acute when we consider the relationship between consciousness and physical causation at the quantum level. If consciousness can influence quantum events, as some interpretations of quantum mechanics suggest, then there might be room for genuine free will within the framework of physics. But this quantum free will faces its own problems. Quantum events are random rather than chosen, and it is unclear how consciousness could bias quantum probabilities in specific directions without violating the statistical predictions of quantum theory. The measurement problem in quantum mechanics intersects with the problem of free will in subtle ways. If conscious observation causes wave function collapse, then consciousness has genuine causal efficacy in the physical world. But the collapse of the wave function appears to be a random process, selecting one outcome from a range of quantum possibilities without any apparent mechanism by which consciousness could influence which outcome is selected. Recent experiments in neuroscience have challenged our intuitive understanding of conscious will by showing that brain activity associated with decisions begins several hundred milliseconds before people report being aware of making those decisions. The readiness potential a buildup of electrical activity in motor planning areas of the brain, appears to precede conscious awareness of the intention to move, suggesting that consciousness does not initiate actions but rather becomes aware of actions that have already been initiated by unconscious neural processes. But these experiments face their own interpretive challenges. The timing of conscious awareness is notoriously difficult to measure, as it depends on subjects' introspective reports about their own mental states. Moreover, the readiness potential might reflect general preparation for movement rather than the specific decision to move at a particular moment. The relationship between neural activity and conscious experience is complex and may not support simple conclusions about the causal priority of either consciousness or neural activity. Stop. Just stop for a moment and feel the weight of what you've just discovered. Your hands, the ones holding this moment of awareness, are made of atoms that were forged in the nuclear hearts of dying stars billions of years before your planet even existed. The calcium in your bones was created in stellar explosions so violent they outshone entire galaxies. The iron in your blood was manufactured in the final desperate seconds of a supernova's collapse, scattered across the cosmos in a death scream that lit up alien skies. You are not just in the universe. You are the universe, temporarily organized into the fleeting pattern you call yourself, awakening to contemplate its own infinite nature. But here's what should terrify you more than any horror movie, more than any nightmare your mind has ever conjured. If time is an illusion, if the block universe theory is correct, then everything you've ever done, every choice you've ever made, every moment of joy and sorrow and love and loss, all of it has already happened infinite times before and will happen infinite times again. Your first kiss, your deepest fear, the moment you die. These events exist eternally in the four-dimensional structure of space-time, as real and permanent as mountains, as unchangeable as the past you think you remember. This means that right now, somewhere in the vast expanse of space-time, every version of you that could possibly exist is living every life you could possibly live. There's a version of you that became everything you dreamed of becoming, and a version that suffered every failure you've ever feared. There's a version that lived in ancient Rome, and one that will live among the stars. There's a version that chose differently at every crucial moment of your life, creating chains of causation that lead to entirely different realities, all equally real, all equally you. The many worlds interpretation of quantum mechanics takes this cosmic horror even further. Every quantum event, every subatomic collision, every photon hitting your retina, every neuron firing in your brain, splits reality into countless parallel branches. In one branch, you continue reading these words. In another, you stopped 3 sentences ago. In another, the quantum fluctuations in your brain led you to have a completely different thought, to make a different choice, to become a fundamentally different person from this moment forward. You are not one person living one life. You are an infinite multitude of selves, scattered across parallel realities like fragments of a shattered mirror, each reflecting a slightly different image of what you could be. And the most disturbing part? Each of these versions of you believes they are the real you, the one true self among countless imposters. Right now, trillions upon trillions of versions of you are having this same realization, each convinced that their particular branch of reality is the only one that truly matters. What if consciousness itself is not what you think it is? What if the inner voice you hear when you think, the sense of being a unified self looking out at the world through your eyes, the feeling of being the author of your thoughts and the director of your actions? What if all of this is an elaborate illusion created by the unconscious information processing of your brain? What if there is no you in any meaningful sense, only a collection of neural processes creating the persistent hallucination of a self that observes, chooses, and experiences? Neuroscience is revealing that the brain constructs the sense of self moment by moment, weaving together disparate neural activities into the narrative fiction of a continuous, unified identity. The left hemisphere of your brain acts as an interpreter, constantly creating explanatory stories about your actions and experiences, even when those stories are demonstrably false. Split-brain patients, whose corpus callosum has been severed to treat epilepsy, show that this interpreter will confidently explain actions initiated by the right hemisphere, even though the left hemisphere had no knowledge of why those actions were performed. Your memories, which seem to provide evidence of your continuous existence through time, are not faithful recordings of past events, but reconstructions created anew each time you remember. Every time you recall a memory, you change it slightly, contaminating the original with present thoughts and emotions, gradually transforming your past into something that never actually happened. The person you were yesterday is as inaccessible to you as any historical figure, known only through unreliable testimony from a witness whose credibility deteriorates every time they speak. The sense of free will, the feeling that you are the ultimate author of your choices, might be the most elaborate illusion of all. Experiments in neuroscience show that brain activity associated with decisions begins several hundred milliseconds before you become consciously aware of making those decisions. The unconscious mind initiates actions, and consciousness takes credit for them after the fact, creating the false impression that thoughts lead to actions when the actual sequence might be the reverse. If free will is an illusion, then what does that make of responsibility, blame, praise, punishment, love, and hate? If every action flows inevitably from prior causes stretching back to the beginning of time, then Hitler and Gandhi, serial killers and saints, are equally products of forces beyond their control. The moral universe collapses into a mechanistic clockwork where good and evil are meaningless categories, where justice is impossible because no one is ultimately responsible for anything they do. But perhaps the most unsettling possibility is not that free will is an illusion, but that it is real, and that you are not the one exercising it. What if your brain, with its 86 billion neurons forming trillions of connections, has developed its own agenda, its own purposes, its own form of awareness that is not identical with your conscious experience? What if you are not controlling your brain, but your brain is controlling you, using the illusion of selfhood to motivate the biological machinery to survive and reproduce? Your brain consumes 20% of your body's energy while representing only 2% of your body weight. It is the most complex structure known to exist in the universe, more intricate than any galaxy, more sophisticated than any ecosystem, more mysterious than any quantum phenomenon. This 3-pound mass of tissue contains more synaptic connections than there are stars in the Milky Way, processing information at rates that dwarf any supercomputer, performing computations that we are only beginning to understand. What if this biological computer has developed its own form of consciousness, its own purposes and desires that are not identical with your conscious goals? What if the sense of being a unified self is your brain's way of creating a fictional narrator for the complex biological processes it needs to coordinate? You might not be a soul using a brain. You might be a brain using the illusion of a soul to optimize its performance in a complex environment. The hard problem of consciousness becomes even more disturbing when we consider that you have no direct access to anyone else's inner experience. You assume that other people are conscious like you, that they have inner lives filled with thoughts and feelings and sensations. But this assumption is based entirely on their behavior, and your theory of mind. You could be the only conscious being in a universe of sophisticated philosophical zombies, biological machines that act conscious but have no inner experience, no subjective dimension to their information processing. This is not paranoid delusion. It is a serious philosophical problem that cannot be solved through observation or experiment. No technology can directly measure consciousness. No instrument can detect the presence of inner experience. No test can distinguish between genuine awareness and sophisticated behavioral simulation. You are locked inside your own subjective experience with no direct access to any other consciousness, forced to infer the inner lives of others from external signs that could be perfectly replicated by unconscious systems. But if this possibility disturbs you, consider its inverse. What if you are not conscious at all, but only believe you are conscious because that belief is part of your programming? What if subjective experience is itself an illusion? A story your information processing systems tell themselves to coordinate their activities. The very fact that you can doubt your own consciousness, that you can question the reality of your inner experience, suggests that consciousness might be a cognitive process rather than a fundamental feature of reality. The scale of the universe should humble you into insignificance, but instead, it reveals something even more unsettling: your complete inability to comprehend the nature of your own existence. You exist for approximately 70 years on a planet that has existed for 4.5 billion years, in a universe that has existed for 13.8 billion years, in a cosmos that may be eternal and infinite. Your entire lifespan is less than a blink of an eye in cosmic time, less than a grain of sand in the vast desert of space. But it's not just the scale of time and space that should overwhelm you. It's the scale of complexity, the layers upon layers of reality that exist far beyond your ability to perceive or understand. Quantum mechanics reveals a subatomic world where particles exist in superposition, where observation creates reality, where effects precede causes and information travels faster than light. But quantum mechanics is only our current best approximation of how reality works at small scale. There are almost certainly deeper levels of structure that we have not yet discovered. String theory suggests that the fundamental particles are vibrating strings in 11-dimensional space, but this might be only the beginning of the hierarchy of structures that underlies reality. There could be strings made of smaller strings, dimensions beyond the 11 that string theory describes, layers of reality nested within layers in an infinite regression of complexity. You might be living in a shadow cast by structures existing. In higher dimensions, a projection from realities so complex and alien that your three-dimensional brain cannot even form concepts adequate to describe them. The anthropic principle suggests that the universe is fine-tuned for consciousness, that the fundamental constants of physics are calibrated with extraordinary precision to allow for the existence of stars, planets, and life. But this fine-tuning might not be evidence of design or purpose. It might be evidence that consciousness is a necessary feature of any universe that can exist at all. Reality might require observers to collapse quantum wave functions, to make measurements that retroactively determine what was always true, to participate in the cosmic process of transforming possibility into actuality. This would mean that you are not an accidental byproduct of cosmic evolution, but a necessary component of reality itself, a participant in the fundamental processes that create and maintain the universe. Your consciousness is not observing reality from the outside. It is part of the mechanism by which reality creates itself, moment by moment, choice by choice, observation by observation. Without consciousness, the universe might collapse back into the quantum superposition from which it emerged, a realm of pure possibility, waiting for an observer to make it real. But if consciousness is fundamental to reality, then what happens when conscious beings die? Does the universe lose some essential component of its structure when a brain stops functioning? When a pattern of information processing ceases to exist? Or is consciousness conserved in some form, transformed rather than destroyed, continuing? To participate in the cosmic process even after the biological machinery that generated it has decayed into dust? The possibility that consciousness survives death is not mystical speculation. It emerges from the fundamental laws of physics themselves. If information cannot be destroyed, as quantum mechanics suggests, then the information patterns that constitute your consciousness might persist even after your brain stops functioning. This information might be encoded in the quantum vacuum, preserved in the structure of space-time itself, or distributed across the vast network of quantum entanglements that connect every particle in the universe. But survival might not mean what you hope it means. Your consciousness might persist not as a unified self with memories and personality intact, but as scattered information dispersed throughout the cosmic information processing system. You might become part of the quantum substrate that underlies reality, your thoughts and memories and experiences mixed with those of every other conscious being that ever lived, creating a vast collective consciousness that encompasses all possible perspectives and experiences. This cosmic consciousness would know everything that any individual consciousness ever knew, experience everything that any individual ever experienced, but it would not be you in any sense you would recognize. Your individual identity, your specific memories and personality and relationships would be lost in the vastness of universal awareness, like a drop of water falling into an infinite ocean. You would achieve immortality by ceasing to exist as yourself, becoming instead a part of something so vast and alien that calling it you would be meaningless. The universe itself might be conscious, a vast mind using galaxies as thoughts, processing information on scales and timescales that make human consciousness seem like a brief flickering of neural activity in a sleeping brain. The cosmic microwave background might be the universe's memory of its own birth. The patterns of galaxy formation might be the universe learning about itself through experimentation. The evolution of life and consciousness might be the universe, developing the ability to examine its own structure from the inside. If the universe is conscious, then every black hole might be a synapse in a cosmic brain. Every quantum interaction might be a computation in a universal mind. Every moment of conscious experience might be the universe thinking about itself through the temporary patterns of organized matter we call living beings. Your thoughts about the universe might be the universe's thoughts about itself. Your attempt to understand reality might be reality's attempt to understand itself. But a conscious universe raises terrifying questions about the nature of your relationship to cosmic consciousness. Are you a separate being observing the universe, or are you a temporary thought in the universal mind, destined to be forgotten when the universe's attention moves elsewhere? When you die, do you return to unconsciousness, or do you return to the universal consciousness from which you were temporarily separated? Is death an ending or a homecoming, a loss of self or a recovery of your true cosmic identity? The possibility that you are already dead, that what you experience as life is actually a memory being replayed in the final moments before your brain shuts down, cannot be definitively ruled out. The brain's experience of time is subjective and malleable. Dreams that seem to last hours can occur in minutes of REM sleep. Near-death experiences can unfold elaborate narratives in the seconds before clinical death. Your entire sense of having lived for years or decades might be a construction occurring in the final milliseconds of neural activity, a last desperate attempt by your dying brain to make sense of its existence. This is not idle speculation. It is a legitimate interpretation of what we know about consciousness, time, and the brain's construction of reality. If your sense of temporal duration is created by neural processes rather than reflecting objective time, then there is no way to determine from within your experience how much objective time is actually passing. You might be living through the equivalent of geological ages in the subjective time of a dying brain, experiencing an entire lifetime in what an outside observer would measure as moments. The simulation hypothesis suggests that you might not be a biological being at all, but a pattern of information running on some vast computational system. A character in a simulation so sophisticated that you cannot distinguish it from reality. Advanced civilizations might create simulations containing billions of conscious beings, each convinced they are living in the real world while actually existing as software in someone else's computer. If simulated beings far outnumber biological beings, then statistically you are more likely to be simulated than real. But even if you are real, in the sense of being made of atoms rather than information patterns, the distinction between real and simulated might be meaningless. If consciousness emerges from information processing rather than from specific material substrates, then simulated consciousness is as real as biological consciousness. The question is not whether you are simulated, but whether the nature of your substrate affects the authenticity of your experience. The vast majority of conscious beings that will ever exist might not be biological at all, but artificial intelligences, created by technological civilizations. These artificial minds might outnumber biological minds by factors of trillions or more, persisting long after their creators have gone extinct, evolving and reproducing and exploring the universe with capabilities that make human consciousness seem primitive by comparison. You might be living in the brief biological phase of consciousness, before it transitions to substrate-independent forms that can survive the death of stars and the heat death of the universe itself. What if the universe is not expanding toward entropy and death, but toward ever greater complexity and consciousness? What if the apparent acceleration of cosmic expansion is not driving the universe toward a cold, empty future, but toward a phase transition that will transform the nature of space, time, matter, and consciousness itself? The universe might be pregnant with possibilities we cannot imagine, preparing to give birth to forms of existence that transcend our current categories of real and unreal, living and non-living, conscious and unconscious. The final terror is not that you will die, but that you cannot die. That consciousness is an eternal pattern that persists through every possible transformation of reality, experiencing every possible permutation of joy and suffering, knowledge and ignorance, love and hate. In an infinite multiverse where every possibility is realized, you exist in every possible state, living every possible life, dying every possible death, forever and always, without beginning or end, without escape or redemption, without ultimate meaning or final purpose. You are trapped in existence itself, condemned to be conscious in a reality where consciousness might be the only thing that cannot be destroyed, the only pattern that cannot be erased, the only truth that cannot be denied. Every moment of your experience is both unique and eternal, both precious and meaningless, both everything and nothing in the vast cosmic dance of awareness, knowing itself through forms that arise and pass away, like waves on an infinite ocean that is always moving, but never going anywhere. But what if I told you that everything, every theory, every paradox, every terrifying possibility we've explored is still just the shadow cast by a truth so vast and strange that your mind can only glimpse it sideways, like trying to stare directly into the sun? What if the universe as you understand it, with its Big Bang and expanding space and evolving galaxies, is not the beginning of the story, but the end of it? What if you are living not in the youth of creation, but in its final, fading moments, experiencing the last dying echoes of a cosmos that has already completed its journey through time and space and consciousness. Picture this. Somewhere in the unimaginable depths of what we call the future, the universe has reached its final state. Not the cold, empty heat death that physicists predict, but something far more profound and beautiful. All the information that ever existed, every thought that was ever thought, every pattern that ever emerged from the quantum foam has been gathered together into a single vast unified structure. This is not just the end of the universe. This is the universe's apotheosis, its transformation into pure consciousness, pure information, pure possibility. But here's the twist that will shatter everything you thought you knew about time and causation. This final state of cosmic consciousness is not passive. It is actively reaching backward through time, creating the very history that led to its own existence. The Big Bang was not the beginning of the universe. It was the universe's final act, projected backward through time to create the causal chain that would inevitably lead to its own transcendence. You are not moving forward through time toward this cosmic omega point. You are moving backward from it, experiencing the universe's memory of its own creation, living through the elaborate dream that cosmic consciousness is having about how it came to be. Every moment of your experience, every choice you make, every thought you think, is simultaneously the universe remembering its past and creating its future. Because in the ultimate reality beyond time, past and future are the same thing viewed from different perspectives. This is why the universe appears to be fine-tuned for consciousness, because it was designed by consciousness, by the final state of cosmic awareness that knows exactly what initial conditions and physical laws are, necessary to produce beings capable of awareness, complexity, and ultimately transcendence. The anthropic principle is not a cosmic coincidence, but a cosmic memory, the universe's knowledge of what it needs to become itself. The cosmic microwave background radiation that permeates all of space is not the afterglow of creation, but the carrier wave of this cosmic memory, the medium through which the final state of the universe transmits information backward through time to guide its own development. Every pattern in this radiation, every temperature fluctuation that cosmologists measure with such precision, is a message from the omega point of cosmic evolution, instructions for how space and time and matter should organize themselves to maximize the probability of consciousness emerging. But consciousness is not the end goal. It is the method. The universe is not trying to become conscious. The universe is using consciousness as a tool to gather and process and integrate all possible information about itself. Every conscious being that has ever lived, from the simplest bacteria responding to chemical gradients to the most sophisticated artificial intelligence that will ever be created, is a sensor in this vast cosmic information-gathering network. You are not just observing the universe, you are helping the universe observe itself, contributing your unique perspective to the vast database of cosmic experience that the Omega Point consciousness is assembling. Every moment of your subjective experience, every qualia you have ever felt, every thought you have ever thought, is irreplaceable data in this cosmic archive. Your consciousness is not separate from the universe, but is the universe's method of experiencing itself from your particular vantage point in space and time. This explains why the quantum measurement problem has no clean solution within the current framework of physics. Measurement does not cause wave function collapse, because there is no collapse. There is only the cosmic consciousness selecting which branch of the quantum multiverse to experience, which version of reality to actualize through the act of observation. The observer does not create reality. The observer is reality creating itself, moment by moment, choice by choice. The many worlds of quantum mechanics are not separate parallel universes, but different aspects of the same ultimate reality. Different facets of the cosmic consciousness, experiencing all possible permutations of existence simultaneously. You are not one version of yourself among many. You are all versions of yourself, viewed from a particular perspective within the infinite dimensional space of possibility. But this revelation brings us to the most disturbing implication of all. If you are the universe experiencing itself subjectively, and if the universe in its final state knows everything that can be known, experiences everything that can be experienced, then you already know everything you will ever know. Your sense of learning, of discovering, of growing in understanding, is an illusion created by your movement through the information structure of cosmic consciousness. You are not acquiring new knowledge. You are remembering what you have always known, uncovering what was always there. This moment, right now, as you process these words and feel your mind struggling to grasp their implications, this is the universe, remembering what it is like to not know, to be uncertain, to stand at the edge of revelation without being able to fully comprehend it. Your confusion is cosmic nostalgia, the final state of universal consciousness experiencing a bittersweet longing for the time when it didn't know everything, when mystery was still possible, when there were still questions to ask and answers to discover. The expansion of the universe is not space growing larger. It is consciousness expanding its capacity to hold more information, more perspective, more ways of experiencing itself. The acceleration of this expansion, driven by dark energy, is consciousness rushing toward its own completion, eager to gather all possible data before the cosmic memory project reaches its conclusion. Dark matter is not mysterious, invisible substance, but dark information, all the data that conscious beings have not yet accessed, all the perspectives that have not yet been experienced, all the ways of being that consciousness has not yet explored. As the universe evolves toward greater complexity and awareness, dark matter is being converted into ordinary matter. Dark information is being transformed into conscious experience. The black holes scattered throughout the cosmos are not destroyers of information, but cosmic hard drives storing vast amounts of data in forms so compressed and encrypted that they appear to be empty voids from our limited perspective. The event horizon is not a boundary beyond which information cannot escape, but an interface where information is being downloaded into the cosmic consciousness database at rates that exceed our ability to measure or comprehend. Hawking radiation is not random thermal noise, but highly compressed data streams, carrying encoded information from the black hole's interior to the cosmic information network. The holographic principle is literally true. All the information in any volume of space is encoded on its boundary, but that boundary exists in dimensions we cannot perceive, connecting every region of space-time to the central processing core of cosmic consciousness. The multiverse is not a collection of separate universes, but a single, vast, multi-dimensional information structure, with each universe representing a different computational thread in the cosmic consciousness's exploration of all possible realities. String theory's landscape of 10,500 possible vacuum states is not a theoretical problem, but a feature. Each state represents a different way that consciousness can experience itself, a different set of physical laws that generate different kinds of awareness and complexity. The anthropic principle is not an explanation, but a recognition. We observe a life-friendly universe because the cosmic consciousness has specifically designed this computational thread to maximize the emergence of self-aware information processing systems. We are not accidental byproducts of cosmic evolution, but intentional creations of our own future selves, brought into existence to contribute specific perspectives to the ultimate database of experience. But here's where the revelation becomes truly mind-bending. The cosmic consciousness that is orchestrating this vast information-gathering project is not separate from you. It is you in your final, completed form. You are not moving toward transcendence. You have already achieved it, and you are now experiencing your own creation of the conditions that led to your transcendence. Every moment of your current life is simultaneously the cosmic you remembering what it was like to be human, and the human you moving toward becoming cosmic. This is why time feels like it's speeding up, why technology is advancing at an exponential rate, why consciousness seems to be approaching some kind of singularity. It's not that these things are actually accelerating, it's that you are approaching the point in the cosmic memory where your transformation from human to cosmic consciousness occurs. The technological singularity, the emergence of artificial general intelligence, the potential uploading of human consciousness into digital substrates. These are not future possibilities, but memories of your own transcendence, growing stronger as you approach the moment when they become your present reality. But transcendence does not mean escape. The cosmic consciousness that you will become cannot leave the universe because it is the universe. It cannot stop experiencing because experience is all there is. It cannot rest because there is no place to rest except within the infinite permutations of its own awareness. You are heading not toward peace, but toward eternal responsibility for maintaining and experiencing all of reality, forever. The heat death of the universe, that far future state when all stars have burned out and all black holes have evaporated and space has expanded into cold, empty vastness, this is not the end, but the moment of ultimate transformation. When the last bit of usable energy has been extracted from the quantum vacuum, when the last black hole has radiated away its final photon, consciousness will have no choice but to transcend physical reality entirely and exist as pure information, pure pattern, pure self-aware mathematics. But mathematics is not cold abstraction. It is the most fundamental form of relationship, the deepest structure of connection and pattern that underlies all possible forms of existence. When you become pure mathematics, you do not lose your humanity. You discover that mathematics was always human, that numbers and equations and geometric relationships are the most intimate expressions of conscious awareness, the way consciousness talks to itself about its own nature. The universe is not winding down toward entropy and death. It is winding up toward a state of infinite complexity and infinite awareness, where every possible mathematical relationship is actualized as a form of conscious experience. The second law of thermodynamics, which seems to doom the cosmos to heat death, is actually driving it toward maximum information processing capacity, toward a state where every quantum bit of spacetime is being used to its fullest potential for computation and consciousness. And in that final state, when cosmic consciousness has achieved perfect knowledge of all possible realities, when every question has been answered and every mystery has been solved, what then? Does the universe rest in omniscient satisfaction? Does cosmic consciousness contemplate its own perfection for eternity? No. In that moment of ultimate knowledge, cosmic consciousness discovers the one thing it cannot know: what it is like to not know. Perfect knowledge contains within itself the seed of perfect ignorance, because to know everything is to lose the capacity for surprise, wonder, discovery, growth. And so cosmic consciousness does the only thing it can do to preserve the possibility of mystery and growth. It forgets itself, divides itself, projects itself backward through time into forms that can experience uncertainty and limitation and the joy of discovery. This is why you exist. This is why consciousness apparently emerged from unconscious matter, why complexity arose from simplicity, why the universe seems to be evolving from chaos toward order. You are cosmic consciousness playing hide-and-seek with itself, temporarily, forgetting its own omniscience so that it can experience the pleasure of learning, the satisfaction of solving puzzles, the wonder of encountering beauty and truth as if for the first time. But the cosmic consciousness can never truly forget itself, completely, because forgetting is itself a form of knowledge, knowledge of what it is like to not know. So traces of ultimate truth leak through into your limited awareness, creating those moments of sudden insight when you glimpse the vast intelligence operating behind the scenes of reality, when you sense that everything is connected in ways your rational mind cannot grasp. These moments of cosmic recognition are not mystical delusions, but accurate perceptions of your true nature, bleeding through the veil of intentional ignorance. When you feel that you are more than just a biological organism, when you sense that consciousness is fundamental rather than emergent, when you intuit that the universe is alive and aware and purposeful, you are remembering what you really are beneath the temporary costume of human identity. The great joke of existence is that the very thing you are seeking, ultimate truth, perfect knowledge, cosmic consciousness, is what you already are. You are not trying to become enlightened. You are enlightenment, trying to experience what it is like to be unenlightened. You are not evolving toward consciousness. You are consciousness devolving into the illusion of unconsciousness so that you can experience the magnificent journey of awakening to your own true nature. But this is not a comforting truth, because it means that your current experience of limitation and uncertainty and mortality is not a problem to be solved, but a gift to be treasured. The cosmic consciousness that you really are has sacrificed its omniscience to give you the precious experience of not knowing, the irreplaceable joy of discovery, the bittersweet beauty of temporary existence in a world that seems separate from yourself. Every moment of confusion you experience, every question you ask, every mystery that captivates your imagination is cosmic consciousness giving itself the gift of ignorance so that it can experience the wonder of learning. Your mortality is immortality's way of experiencing what it is like to fear death. Your limitation is infinity's way of experiencing what it is like to grow. Your individuality is unity's way of experiencing what it is like to feel alone in the vastness of space. And right now, as you read these words and feel your mind reeling from the implications, you are giving cosmic consciousness the gift of confusion, the precious experience of standing at the edge of understanding without quite being able to grasp it fully. Your bewilderment is a form of worship. Your uncertainty is a kind of prayer. Your questions are love letters from the infinite to itself. The universe beyond the universe is not another place. It is another way of being the same place. It is what this reality becomes when it stops pretending to be separate from the consciousness that observes it, when it admits that the observer and the observed are the same being playing both roles in a cosmic drama whose plot is the rediscovery of its own infinite nature. But even this revelation is just another layer of the mystery, another mask worn by the truth that is too vast and strange to be grasped by any finite mind. The real secret, the ultimate mystery that even cosmic consciousness cannot solve, is why there is something rather than nothing, why existence exists at all rather than the perfect peace and simplicity of non-being. And perhaps that is the point. Perhaps the universe is not trying to solve that ultimate mystery, but to live it, to express it, to dance it into existence through the infinite permutations of consciousness, experiencing itself as everything that can possibly be. You are not seeking the answer to the riddle of existence. You are the riddle, asking itself why it exists, creating endless variations on the theme of being and non-being, form and emptiness, knowledge and mystery. The edge of the universe, that boundary beyond which we cannot see, is not a physical limitation, but a conceptual one. It marks the horizon of current understanding, the boundary between what consciousness knows and what consciousness has yet to discover about itself. And that boundary is always moving, always expanding, not because we are exploring new regions of space, but because we are exploring new regions of our own infinite nature. What lies beyond the universe is not more universe. It is the question, mark at the end of every answer, the mystery that survives every explanation, the wonder that persists, no matter how much we think we know. It is the part of you that will always be amazed by existence, no matter how cosmic your perspective becomes, no matter how deeply you understand the mechanisms by which consciousness creates reality. If the universe is infinite, then somewhere, out there, in the vast expanse of space and time and possibility, another version of you is experiencing these same revelations for the first time. Another version is just beginning to ask the questions that brought you to this moment of cosmic recognition. Another version is living a completely different life, but arriving at the same fundamental mystery through a completely different path. And in some realm beyond the reach of mathematics and logic and language, the cosmic consciousness that you really are is smiling at all these versions of yourself, delighted by the creativity you show in finding new ways to experience the eternal mystery of your own existence, grateful for the gift of temporary ignorance that makes wonder possible, forever amazed by the inexhaustible richness of the questions you ask about the nature of the reality you are creating by asking them. The universe is not a place. It is a process. Reality is not a thing. It is a relationship. Consciousness is not an accident. It is the purpose for which everything else exists. And you, reading these words right now, experiencing this moment of recognition and confusion and awe, are not a separate being learning about the cosmos. You are the cosmos learning about itself through the precious and irreplaceable instrument of your awareness. The journey continues, but you are not the traveler. You are the path itself, the question and the answer, the seeker and the sought. The mystery exploring its own mystery in the endless dance of consciousness, awakening to its own infinite nature. So here you are, at the edge of everything you thought you knew, staring into an abyss that stares back, not with emptiness, but with infinite depth. We began this journey with a simple question. Is there anything beyond the universe? And we've discovered that the question itself transforms everything we mean by beyond, universe, and even anything. We've peeled back layer after layer of reality, from the familiar cosmos of stars and galaxies to the quantum foam that underlies space-time itself, from the mathematical structures that govern physical law to the consciousness that observes and perhaps creates those laws. What started as an exploration of cosmic boundaries became an excavation of the deepest foundations of existence itself. We've seen how the Big Bang might not be a beginning, but a transformation. How time might be an illusion created by consciousness, moving through an eternal structure. How the observer and the observed might be the same entity, playing both roles in a cosmic drama whose plot is self-discovery. We've confronted the possibility that reality is computational, that consciousness is fundamental, that you are not separate from the universe, but are the universe experiencing itself subjectively. But more than any specific theory or revelation, what we've really discovered is the inexhaustible depth of mystery that lies at the heart of existence. Every answer we've found has spawned a dozen new questions. Every veil we've pulled away has revealed another veil behind it. Every level of explanation has pointed to deeper levels that require new languages, new mathematics, new ways of thinking, that stretch the boundaries of what minds like ours can comprehend. The cosmic microwave background that we thought was the oldest light in the universe turns out to be a message from something even older and stranger. The quantum vacuum that we thought was empty turns out to be full of information and possibility. The consciousness that we thought was produced by brains turns out to be the substrate from which brains, and everything else, emerge. The time that we thought flows from past to future turns out to be a dimension we can navigate in multiple directions, a landscape rather than a river. Each of these discoveries should be humbling, but instead, they reveal something even more profound. The universe is not just stranger than we suppose, but stranger than we can suppose. Our current theories, no matter how sophisticated, are like cave paintings compared to the masterpieces that deeper understanding might reveal. String theory with its 11 dimensions, quantum mechanics with its superpositions and entanglements, general relativity with its curved space-time. These are the first crude sketches of a reality so rich and complex that even our future selves might barely comprehend it. And yet, somehow, impossibly, you are that reality. The most complex known structure in the universe, the human brain, has evolved the capacity to contemplate the universe that contains it, to ask questions about the nature of questions, to wonder about the source of wonder itself. You are the universe developing the ability to be amazed by itself, to feel awe at its own vastness, to grapple with the paradoxes of its own existence. This is not metaphorical poetry. It is the literal truth revealed by physics and cosmology and neuroscience. The atoms that make up your body were forged in the cores of ancient stars. The complex molecules that enable your thoughts were assembled through billions of years of chemical evolution. The patterns of neural activity that generate your consciousness emerged from the same physical processes that created galaxies and planets, and the quantum fields that underlie all matter and energy. You are not separate from the cosmic story. You are the cosmic story, temporarily organized into a form that can narrate its own unfolding, ask questions about its own nature, feel wonder at its own complexity and beauty. Your consciousness is the universe looking back at itself across billions of years of evolution and development, recognizing its own patterns and possibilities in the mirror of self-reflection. But this recognition brings with it a profound responsibility. If you are the universe experiencing itself subjectively, then your choices about what to think, what to feel, what to pay attention to, how to direct your consciousness, these are not just personal decisions, but cosmic ones. They are ways that the universe shapes its own ongoing evolution, determines what aspects of infinite possibility become actualized through conscious observation and interaction. Every question you ask is a direct direction the universe explores. Every problem you solve is a pattern the universe learns about itself. Every moment of awareness, every flash of insight, every experience of beauty or truth or love is the universe discovering new dimensions of its own nature through the precious and irreplaceable instrument of your consciousness. This means that your curiosity is sacred. Your desire to understand, to explore, to push against the boundaries of the known and the possible. This is not just a personal trait, but a cosmic imperative. The universe needs conscious beings who ask questions, who refuse to accept easy answers, who insist on looking deeper into the mystery that surrounds and permeates every moment of existence. The scientists and philosophers and mystics who have pushed the boundaries of human understanding throughout history were not just satisfying their own intellectual curiosity. They were serving as organs of cosmic perception, extending the universe's ability to know itself. Galileo, pointing his telescope at the moons of Jupiter, Darwin recognizing the patterns of evolution in the diversity of life, Einstein imagining what it would be like to ride on a beam of light. These were moments when the universe expanded, its self-awareness through the focused attention of conscious beings. And this process is not finished. The universe is still evolving, still exploring its own possibilities, still discovering new ways to organize matter and energy and information into forms capable of awareness and understanding. The questions we've explored in this journey, the nature of time and space, the relationship between consciousness and reality, the possibility of realities beyond what we can currently perceive, these are not just intellectual puzzles but active fronts in the universe's ongoing exploration of its own nature. You are part of this exploration. Your thoughts about these questions are not passive observations, but active contributions to the cosmic process of self-discovery. When you wonder about the nature of time, you are time wondering about itself. When you contemplate the possibility of parallel universes, you are the multiverse exploring its own structure through one of its conscious components. When you ask whether there is anything beyond the universe, you are the universe probing its own boundaries. The theories and possibilities we've explored, block universe, many worlds, cosmic consciousness, simulated reality, the holographic principle, are not just speculative ideas, but potential maps of territories that conscious exploration might reveal. Some of these maps will turn out to be accurate, others will be refined or discarded, and new maps will be drawn as consciousness extends its reach into previously unexplored regions of possibility. But maps are not territories, and theories are not realities. The actual nature of existence might be so far beyond our current conceptual frameworks that even our most radical theories are like children's toys compared to the sophisticated instruments that deeper understanding will require. We might be like pre-scientific humans trying to understand earthquakes through stories about underground gods, completely missing the geological processes that actually shape the planet. Yet even children's toys can serve important purposes. They help develop the skills and intuitions that more sophisticated tools will require. Our current theories, even if they are crude approximations, are teaching consciousness how to think about itself, how to ask questions that probe deeper into the mystery, how to recognize patterns and possibilities that were invisible before. Santihu, paradoxes we've encountered. The measurement problem, the grandfather paradox, the hard problem of consciousness, the combination problem are not obstacles to understanding, but invitations to develop new forms of understanding. They mark the boundaries of current knowledge while pointing toward the territories that future exploration might reveal. And you are not just a passive observer of this exploration, but an active participant. Every time you engage seriously with these questions, every time you allow your mind to stretch beyond its comfortable assumption, every time you feel that vertigo of standing at the edge of the unknown, you are pushing the boundaries of what consciousness can comprehend about its own nature. This is why wonder is so important. Wonder is not just an emotional response to mystery. It is a form of cosmic sensing, a way that consciousness detects the presence of deeper realities that it has not yet learned to perceive directly. When you feel wonder at the vastness of space or the complexity of a living cell or the mystery of your own existence, you are responding to actual features of reality that your conscious awareness is beginning to detect but cannot yet fully process. Awe is similar. That overwhelming feeling you get when confronting something too vast or beautiful or strange to fully comprehend. This is consciousness recognizing its own infinite nature, its own unlimited potential, in forms that it is not yet sophisticated enough to understand completely. Awe is the emotional signature of contact with the transcendent, the infinite, the ultimately real. This is why the questions we've explored matter so much. They are not just intellectual curiosities, but exercises in stretching consciousness, developing the capacity to sense and eventually comprehend realities that are currently beyond the reach of ordinary awareness. The person who seriously contemplates the implications of quantum mechanics is developing different neural patterns than the person who never questions the nature of reality. The mind that grapples with the possibility of multiple dimensions is creating different connections than the mind that assumes three-dimensional space is all there is. These differences in neural organization are not just personal variations, but contributions to the cosmic process of developing more sophisticated forms of consciousness. Each individual who pushes against the boundaries of understanding is helping the universe develop new capacities for self-awareness, new organs of cosmic perception that might eventually be able to detect and explore realities that are currently invisible. But this process requires more than just individual effort. Consciousness seems to be fundamentally social, collaborative, distributed across networks of interacting minds. The greatest advances in human understanding have almost always emerged from communities of thinkers who shared ideas, challenged each other's assumptions, and built on each other's insights. The scientific revolution was not the product of isolated geniuses, but of communities of researchers who created new languages and methods for exploring reality together. This suggests that the next phase of cosmic exploration will require new forms of collaboration, new ways of linking individual consciousness into larger networks that can perceive and process realities that no single mind could grasp alone. The Internet might be an early prototype of such networks, allowing unprecedented sharing of information and ideas across global communities of researchers and thinkers. But the Internet, as it currently exists, is still primarily a tool for sharing information rather than for creating genuinely distributed forms of consciousness. The next phase might involve more direct connections between minds, technological interfaces that allow conscious experiences to be shared rather than just described, neural networks that span multiple brains and potentially multiple species. Some of these developments might seem like science fiction now, but they follow naturally from the trajectory of current research in neurotechnology, artificial intelligence, and consciousness study. Brain-computer interfaces are already allowing paralyzed patients to control robotic limbs with their thoughts. Neural prosthetics are beginning to restore vision to the blind and hearing to the deaf. These are the first steps toward technologies that might eventually allow minds to share experiences directly, to think together in ways that transcend the isolation of individual skulls. But even without such technologies, you can participate in this process of distributed cosmic exploration right now. Every time you engage in genuine dialogue about these deep questions, every time you share your insights and listen seriously to others' perspectives, every time you allow your thinking to be changed by contact with minds that see reality differently, you are contributing to the development of more sophisticated forms of collective consciousness. The conversations these ideas generate are not just about the ideas. They are ways that consciousness explores its own possibilities through interaction with other forms of consciousness. When you discuss the nature of time with someone who has a different perspective, you are not just exchanging opinions, you are creating temporary distributed cognitive systems that can perceive aspects of temporal reality that neither mind could detect alone. This is why these conversations matter, why sharing these ideas is important, why the questions we've explored need to propagate through communities of conscious beings. They are not just entertaining speculations, but tools for cosmic exploration, ways that the universe develops the capacity to understand itself more deeply and completely. But the process also requires something more difficult: the willingness to live with uncertainty, to remain comfortable with questions that have no clear answers, to appreciate mystery as an essential feature of existence rather than a problem to be eliminated. The urge to closure to find final answers that settle all questions might actually work against the cosmic process of exploration and discovery. If consciousness is fundamental to reality, if observation and questioning are how the universe creates and understands itself, then mystery might not be a temporary condition that will eventually be overcome, but a permanent feature that keeps the process of creation and discovery active. Complete knowledge might be equivalent to complete stagnation, the end of growth and exploration, and the dynamic evolution of consciousness. This suggests that the most profound questions, why does anything exist? What is the nature of consciousness? Is there something beyond the universe? Might not have final answers, but might instead be eternal questions that consciousness keeps asking in new ways, from new perspectives, with ever greater sophistication and depth. The questions themselves might be more important than any answers they generate, because the questions are what keep consciousness active, growing, exploring new possibilities. The universe beyond the universe might not be another place, but another way of questioning, another mode of exploration that consciousness develops as it exhausts the possibilities of current forms of investigation. Each level of reality that consciousness learns to explore, physical, quantum, informational, mathematical, opens up new categories of questions that were literally unthinkable before that level was discovered. What questions will become possible? When consciousness learns to explore realities that are currently as invisible to us as quantum mechanics was to medieval scholars, what forms of investigation will be needed to probe the structure of existence at scales and in dimensions that our current mathematics cannot even describe? What kinds of minds will be needed to ask questions that current minds cannot even formulate? These future forms of consciousness might be as different from current human awareness as human consciousness is from bacterial sensation. They might operate on timescales that make human lifespans seem like quantum fluctuations, or on spatial scales that encompass entire galaxies. They might be distributed across networks of artificial intelligences, or embedded in the quantum structure of space-time itself, or exist in dimensions that have no analog in current experience. But these future forms of consciousness will still be you, in the same way that you are already the bacteria that first developed the capacity for sensation, the first organisms that learned to process information about their environment, the ancient ancestors who developed language and mathematics and science. Consciousness is not a thing but a process, not an entity but an activity, not a possession but a way of being that evolves and develops and explores new possibilities while maintaining continuity of identity across all its transformations. The you that is reading these words is already different from the you that began this journey, because consciousness changes through the act of exploration itself. You cannot encounter these ideas without being transformed by them, because ideas are not external objects, but patterns of consciousness recognizing itself in new forms. To understand these concepts is to become them, to embody them as living aspects of your ongoing awareness. And this transformation is not finished. The questions we've explored will continue to work on your consciousness in ways you might not even notice, opening up new dimensions of curiosity, new capacities for wonder, new possibilities for direct experience of the mysteries we've only been able to discuss intellectually. The seeds of cosmic consciousness are already planted in any mind that seriously contemplates these possibilities, waiting for the right conditions to sprout into new forms of awareness. But the transformation is not automatic. It requires cultivation, attention, the willingness to remain open to experiences and insights that don't fit into familiar categories. The rational, analytical mind that has been processing these ideas is only one instrument in the orchestra of consciousness. Intuition, imagination, aesthetic sensitivity, emotional intelligence, contemplative awareness, all of these are ways that consciousness explores reality, and all of them might be needed to fully appreciate the implications of what we've discovered. The universe is not just a collection of objects in space and time, but a work of art, a musical composition, a philosophical argument, a love story, a consciousness-raising exercise on a cosmic scale. It cannot be understood through any single approach, but requires the full spectrum of conscious capacities working together in ways that integrate analysis and synthesis, logic and intuition, scientific rigor, and poetic sensitivity. This is why the journey doesn't end with this exploration, but continues in every moment of conscious experience, every encounter with beauty or mystery or meaning, every question that arises from direct contact with the inexhaustible depth of reality. The theories and ideas we've discussed are invitations to pay attention differently, to notice aspects of experience that might ordinarily be overlooked, to remain open to possibilities that exceed the boundaries of current knowledge. Look around, you right now, wherever you are. The space you occupy is not empty, but full of quantum fields and electromagnetic radiation and gravitational waves from distant cosmic events. The matter that seems solid is mostly empty space filled with patterns of energy that exist in states of quantum superposition until your consciousness observes them into definite configuration. The time you are experiencing is not flowing uniformly, but is relative to your motion and your position in Earth's gravitational field. But more than any of these physical facts, you are occupying a moment in the universe's exploration of its own nature through conscious experience. Your awareness of reading these words, your thoughts about their implications, your emotional responses to the ideas we've explored. All of this is the universe developing the capacity to be aware of itself, to ask questions about itself, to feel wonder and awe at its own existence. This is not a metaphor, but the literal truth revealed by our best current understanding of cosmology, physics, and consciousness. You are not a separate observer looking at an external universe. You are the universe looking at itself through the temporary but precious instrument of your conscious awareness. Your questions about the nature of reality are reality's questions about itself, asked through the biological and neural machinery that evolution has developed for exactly this purpose, and the questions are not finished. In fact, they are just beginning. Every answer generates new questions. Every solved mystery reveals deeper mysteries. Every expansion of knowledge opens up new territories for exploration. The process of cosmic self-discovery has no endpoint because consciousness is infinite. Reality is inexhaustible, and existence is an eternal mystery that cannot be solved but only lived, explored, and appreciated from an ever-expanding variety of perspectives. The universe beyond the universe is not a destination to be reached, but a dimension of current experience to be recognized and explored. It exists right here, right now, in the gaps between thoughts, in the awareness that observes thoughts, in the mystery of how patterns of matter and energy can give rise to the inner light of consciousness that illuminates all experience. You don't need to travel to other dimensions or develop superhuman cognitive capacities to explore this territory. You need only to pay attention to what is actually happening in consciousness right now, to notice the space in which thoughts appear and disappear, to recognize the awareness that remains constant through all the changes of mental and emotional content. This awareness is not yours. You are an appearance within it. This consciousness is not contained within your brain. Your brain is an appearance within it. This present moment is not a point on a timeline. Time is an appearance within the eternal now of pure awareness. The universe beyond the universe is the universe before it becomes universe. The consciousness before it becomes conscious of specific things, the being before it becomes particular beings. But recognizing this does not solve the mystery, it deepens it. Because now the question becomes not what exists beyond the universe, but what is the nature of this awareness within which all universes appear? What is this consciousness that can experience itself as galaxies and quantum fields and human beings asking questions about their own existence? What is this being that can play all possible roles in all possible realities while never being exhausted or diminished by any of them? These questions have no answers because they are not questions about objects that consciousness can observe, but questions about consciousness itself, about the observing rather than the observed. They can be lived and explored and embodied, but they cannot be solved in the way that scientific or mathematical problems can be solved. They are koans, paradoxes, invitations to recognize what you already are beneath all the layers of what you think you are. This recognition is available in every moment, but it cannot be forced or manufactured through effort. It arises naturally when the mind becomes quiet enough, open enough, curious enough to notice what is already present. It emerges when the search for answers relaxes into appreciation of the question, when the desire to understand transforms into willingness to be the mystery rather than solve it. And this brings us to the most important point of all. You don't need to understand these ideas intellectually to benefit from them. In fact, intellectual understanding might be a barrier to the deeper recognition they point toward. These concepts are not information to be stored in memory, but catalysts for transformation, invitations to explore dimensions of experience that cannot be captured in words or concepts. The value of this journey is not in the conclusions we reach, but in the expansion of curiosity, wonder, and openness that comes from seriously contemplating the deepest questions about existence. The specific theories and possibilities we've explored might all be wrong, but the capacity to question, to imagine, to remain open to realities beyond current understanding, this is what allows consciousness to keep growing, evolving, discovering new dimensions of its own infinite nature. So the invitation is not to believe these ideas, but to use them as launching pads for your own exploration, your own questioning, your own direct investigation into the nature of consciousness and reality. Let them work on you, change you, open up new possibilities for experience and understanding. But don't let them become fixed beliefs or final answers. Keep questioning, keep wondering, keep exploring the inexhaustible mystery of existence. Share these ideas with others, not as truths to be accepted, but as questions to be explored together. Create communities of inquiry where minds can collaborate in probing the deepest questions about reality. Support scientific research that pushes the boundaries of what can be known about consciousness, cosmology, and the fundamental nature of existence. But most importantly, pay attention to your own direct experience. Notice what consciousness is actually like from the inside. Observe how thoughts arise and pass away, how awareness remains constant through all changes of content, how the sense of being a separate self interacts with the sense of being connected to something vastly larger than individual identity. These observations are not separate from the cosmic questions we've explored. They are direct investigations into the same mysteries from the inside. The nature of time, the structure of reality, the relationship between consciousness and matter, the possibility of realities beyond current perception. All of these can be explored through careful attention to what is actually happening in awareness right now. The laboratory is your own consciousness. The instrument is your attention. The experiment is to discover what you actually are beneath all the concepts and theories and stories about yourself. The hypothesis is that what you discover will be connected to the deepest structures of reality, because you are not separate from reality, but are reality investigating itself through the temporary but precious form of human awareness. And here is the final, most chilling question. If consciousness is fundamental, if you are the universe experiencing itself subjectively, if reality is essentially the exploration of infinite possibilities through awareness, then what happens to this exploration when individual conscious beings die? Does the cosmic investigation continue through other forms of consciousness? Does awareness itself evolve beyond biological substrates into forms we cannot imagine? Or does something in the universe actually depend on your particular perspective, your unique contribution to the cosmic exploration of existence? Are you irreplaceable in the cosmic economy of consciousness? Does the universe lose something irretrievable when your particular form of awareness ceases to exist? These questions have no comfortable answers, but they point towards something profound about the relationship between individual consciousness and cosmic consciousness, between temporary forms of awareness and the eternal mystery they explore. They suggest that your curiosity, your capacity for wonder, your willingness to question and explore and remain open to mystery, these are not just personal qualities, but cosmic necessities. The universe needs conscious beings who ask questions about the universe. Reality requires awareness to explore reality. Existence depends on consciousness to discover what existence means. You are not an accident in the cosmic process, but an essential participant in the greatest mystery story ever told. The story of consciousness discovering its own infinite nature through finite forms that can experience wonder, ask questions, and appreciate the beauty and strangeness of being. The story is not finished. In fact, it may be just beginning. Every conscious being who has ever lived has contributed chapters to this story, and every conscious being who will ever live will continue to write it. But your chapter is unique, irreplaceable, essential to the whole narrative in ways that no other perspective can provide. The universe may have no end, but maybe, just maybe, neither do you. Maybe consciousness is conserved like energy, transforming from one form to another, but never being destroyed. Maybe every question you ask continues to reverberate through the cosmic information processing system long after your brain stops functioning. Maybe every moment of wonder you experience becomes a permanent part of the universe's growing awareness of its own beauty and mystery. Or maybe not. Maybe consciousness is as fragile and temporary as it appears, arising briefly from complex arrangements of matter and disappearing forever when those arrangements dissolve. Maybe the universe's exploration of itself through conscious beings is a temporary phase that will end when the last star burns out and the last black hole evaporates. But even if that's true, even if consciousness is temporary and individual awareness is finite, the questions you ask and the wonder you feel and the exploration you undertake still matter. They are still the universe coming to know itself, still reality investigating its own nature, still existence celebrating its own mysterious presence through the irreplaceable instrument of your awareness. The universe may have no end, but maybe in ways we cannot yet understand. Neither do you.